Newton. Then we people have seen the strain gauge. So what is strain gauge? Strain gauge is nothing but a wire that consists of a length and it consists of a diameter also. So when a force is exerted on that particular wire, if I want to represent that particular wire at that time, suppose we are having, this is the strain gauge filament, and if we try to apply a force on this particular instant, automatically the length of this strain gauge, by applying a force, it is going to change. So at the first instant, we people were having the length L, and after applying a force, we are getting the change in length, that is delta L. So over here, what changes we are getting after applying this force F on the strain gauge is nothing but change in length, or so your this particular material used is the piezo resistive material has been used for the designing of this particular strain. Now, this we have even seen the derivation of the strain gauge. So, what things we have in the previous lecture that we have covered, that we people will try to recall. First of all, the application. Now, what are the different applications that can be measured using your strain gauge? So, you can use to measure pressure, you can use to measure force, you can use to measure displacement, and etc. There are large number of applications that can be measured using your strain gauge. Okay, using strain gauge. So I have specified some of the common application. Even torque can be measured. Torque can be measured using your strain gauge. As we people are studying force and torque measurement, so we people will try to concentrate on the measurement of force and torque by using a force strain gauge type of transducer. Secondly, we have tried to derive an expression for the gauge factor, that is nothing but the lambda, which has been specified as a dr by r change in resistance with respect to resistance divided by change in length to the length. So this particular derivation we people have derived based upon the formula, that is R is equal to rho L by A, where R is the resistance of the material, rho is the resistivity of the material, L is the length of material, and A is your cross-sectional area of the material. By taking a derivative, we have tried to resolve the entire derivation to determine the gauge factor, because gauge factor is playing a significant role in terms of the sensitivity. Okay. Then we have seen the different composition or the material that has been used for the strain gauges, or the composition of the material to develop or design a strain gauge. Finally, bounded type of metal foil strain gauge we have studied, and in this particular lecture we people are going to concentrate on the semiconductor type of strain gauge. The gauge length, different composition, along with the different composition, what are the gauge factor and what is the composition of the material that we have seen. I have provided one table, and in that table the entire constraint of the uh, composition and gauge factor along with the material were provided. Then baking material. So what is the baking material or the base material that is used? Because even you people can use the PCB, one of the PCB technique. Now why I am saying PCB technique? The reason is that the etching process can be carried out. Suppose what is that particular etching process? I am having the baking material or I am having the material, that particular material, if I have surrounded this particular material, this is the material that has been used. And on this particular material, if I try to design something, suppose this is the device which I am using for the designing purpose. What it means is this particular part, which part, this this white part is going to remain, means that has been vanished from the entire region, and only the white part which is concerned with this particular design is going to remain same, is going to be sustained by placing this particular piece in a chemical process, that is the etching. This process we people are trying to carry out to develop a circuit on the PCB board, copper clad PCB board. Similar aspect is used, that material, actually this board or the material is a piezoresistive type of material. It means that you are trying to extract or you are trying to generate the circuit. That circuit will have the material on it, and that material will act as a strain gauge. Okay. Then adhesive material that supports it and the bounding of the adhesive material, its property or the characteristics also we people have seen, and what are the problems that can be caused due to the adhesive material or variation in the temperature may cause, that can also be taken under consideration. And in this particular lecture, we people are going to study a semiconductor gauges. So after completion of this lecture, you people will be able to specify the different types of semiconductor strain gauges, its merit, demerits. What is the major demerit? That is nothing but actual over here the problem of temperature effect which is going to take place due to the semiconductor material for semiconductor strain gauge that has been arise, and how that problem can be overcome will be uh, resolved or will be provided to you people. And at the last of the lecture you people can specify the mean, that is temperature compensation by using a dummy strain gauge. Then advantages, disadvantages of the strain gauge, and one of the problem we have solved in this lecture. Okay. So the contents that we are going to cover in this lecture is application of strain gauges. No doubt we have already seen all these particular parts, that is application of strain gauges, derivation, composition material, bounded foil, gauge length, baking material, adhesive material, and in this